The reason why we need to be able to calculate the present value of an annuity is, in lots of word problems you'll encounter, there will be talking about, you borrow some amount of money today and you pay it back in installments. So those are really the main types of word problems that you will find. So if you have a large lump sum to invest today and you need to withdraw money from an account to, let's say, pay off bills or because you want to use that money for something, okay, or you want to calculate how much you would have to pay back a loan every period, so every month, every day, every week, etc. Those are the kind of word problems that would require you to use the PV formula. So how do you know when a scenario requires you to use the PV formula rather than the future value formula that we went over yesterday? And if you remember, well, let's see if I remember. R bracket 1 plus I over C to the NC minus 1 I over C. So that's the future value of an annuity formula. Okay. Or the regular compound interest formula. So how do you know? How can you distinguish between all these different types? Well, in the problem, if you see anything about withdraw or again, withdraw, sorry, I'm not going to put the slash there, each, okay? So withdraw every month, withdraw every week, or if you see invest some amount today to pay something every each, again, those keywords, okay? If anything about a loan comes up, okay, generally speaking, then you would have to use the PV formula. All right, now let's move on to the next page for the example. All right, if you're given the present value of an annuity and you need to determine the amount for the regular payments R, then just like we did before, we could just rearrange our equation and solve for R. So I'm going to multiply both sides by I over C, and that way I would have PV times I over C equals R times 1 minus 1 plus I over C to the negative NC. And then I want to move this entire bracketed expression to the other side. So I'm going to divide both sides by that. So I would end up with R is equal to PV times I over C divided by 1 minus 1 plus I over C to the negative NC. Okay. So in the second example, I go to the movies often. True story. I decide to invest my savings of $750 into an account that pays an interest of 2.1% compounded bi-weekly. So here is my I. If I'm compounding bi-weekly, then C is equal to 26. Savings of $750, that would be the p-value. How much money would I be able to withdraw every 2 weeks? Okay, so there's that keyword every. That indicates this is a present value of an annuity problem and not just a regular compound interest problem. For the next year for my movie excursions. All right, let's check this out. PV times I over C, 1 minus 1 plus I over C to the negative NC. Okay. So present value is $750. Interest 0.021 divided by 26 all over 1 minus 1 plus 0.021 over 26 to the power of negative 1 year times 26 times a year. Okay. When you're solving on your calculator, again, I would recommend that you take care of what is in your denominator first. So 0.021 divided by 26 plus 1 to the power of negative 26. 1 minus that answer, and then the entire numerator divided by the answer that you just got. So $29.16. Great. For part B, I'll finish this example in the next video.